Okay, we're going to look at a rational function of the form linear over linear. And instead of having just a 1 in front of x, just a plain x, if we've got a 6 in front of this x and a 2 in front of this x. That is no problem, because what we do, first thing we do in analyzing a rational function is determine where the numerator has zeros and where the denominator has zeros. So the numerator is 6x plus 5. Set that equal to 0, and you find that x is negative 5/6. And of course, when the numerator is 0, if the denominator isn't 0, you're going to have a 0 of the function, which I usually indicate with an x. We're going to go through this point. The graph has got to go through this point. Okay? The denominator is 0 when 2x minus 3 is 0. The solution to that is x equals 3/2. Now, when the denominator is 0 and the numerator isn't, that's got to give you an asymptote, vertical asymptote. So you have a vertical asymptote at x equals 3/2. Now this is all, should be all very familiar. To the left of negative 5/6, the numerator is negative, and the denominator is negative. So over here we have two negatives, which give us a positive. So the graph comes down from up here somewhere, or from somewhere over here. Turns out actually it doesn't come down from real high. We'll see what it does. So we have negative 5, anyhow we have the 0 at negative 5/6, and we're going to approach that through positive numbers. We'll have an asymptote at 3/2, a vertical asymptote. Now between negative 5/6 and 3/2, the numerator 6x plus 5 is positive, but the denominator is negative. So we're negative between these 2 points. And then to the right of this point, both factors are going to be positive. The graph is going to be above the axis. Now we could do that in a number of ways. The function came down from way up here, which it doesn't, as we'll see. It could come through here, come around, and then approach this vertical line as an asymptote. And then it could come down here, it could wiggle around, it could do anything. Well, it actually can't do just anything, but as far as we know right now, it could. Okay? So let's analyze just a little further to see what happens. Now, by just a little bit of simple reasoning, and the kind of reasoning we've done, if x is a huge number, whether positive or negative, the 5 and the negative 3 don't make much difference. You end up with pretty much 6x over 2x, and 6x over 2x is just 3. And for that reason, we have a graph approaching a horizontal asymptote at y equals 3. I think I said x equals 3 a minute ago. It's y equals 3. Okay? So just by thinking numerically, we can see that we have a graph that's going to approach y equals 3. So what's going to happen as we go to the left, we have to approach y equals 3, because that's where the big x values are, negative x values. So it's going to come through here, and come down here, and it's going to dive on down to an asymptote. On the other side of the asymptote, it's going to come down from large positive values and might well just approach the horizontal asymptote in the simplest possible way. So actually, this is probably a fairly good picture of what this function does. I want to analyze it just a little further to see how this function deconstructs. But if you know this much, you're doing okay. If you want to really ace the course, really understand everything, we can do this. We can do a long division. 2x minus 3 into 6x plus 5. That's going to be a pretty short division. 2x goes into 6x 3 times. Okay, so whatever the quotient is, you've got to have a 3 there. Well, that's your asymptote, your horizontal asymptote. You multiply 3 by 2x minus 3, you get 6x minus 9. Okay? And then if you subtract minus 9 from the 5, you get 14. This is your remainder. Remainder 14. So we could write this as 3 plus 14 over 2x minus 3. Now 14 over 2x minus 3 is really just a transformation of the 1 over x function. Won't go into the details of the transformation, but this is exactly the shape the graph would have. Well, I say exactly. I don't have all the symmetry here, but the graph is going to have this nature. It's a transformed 1 over x function. And this looks like a transformed 1 over x function. Shifted over 3/2 of a unit and up 3 units. Put a couple of axes here. It's going to be asymptotic to these axes. Okay, because you're multiplying the x by 2, it's also going to compress or expand the thing in the horizontal direction. And if you understand horizontal compression, you see it's going to be compressed by a factor of 2. It's going to be steeper than the 1 over x graph, but it's going to look like this. Now again, that last part about the division and how these two graphs superpose, if you're working to really learn everything you can in the course, that's something worth knowing. Otherwise, you can probably do without it.